Good day everyone. Today we are going to start with the part 3 of electrochemistry. We have already completed until the Nernst equation, and today we will be starting with the conductivity of electrolytic solutions and its measurements. So first, let us study some important terms related to conductance of electricity. So first we will be studying about resistance. So resistance is defined as the hindrance provided by a conductor to the passage of electricity. So every substance offers resistance to the flow of electricity. It may be large or small in extent. So the electrical resistance R of any object is directly proportional to its length and is inversely proportional to the area of cross section. So when we remove the proportionality sign, we get a constant which is called resistivity or specific resistance of the object. So now we'll study what is resistivity. So resistivity is defined as the resistance offered by a substance of 1 meter length with area of cross section equal to 1 meter square. So if we take the length to be 1 meter and area to be 1 meter square, then we'll get the resistivity of a substance. So the units are ohm, centimeter square by centimeter. So further we can write it to be ohm meter or ohm centimeter. Now we'll study what is the conductance. But the IUPAC will recommend the RAM as resistivity over specific resistance. Now conductance. So conductance is the ease with which current flows through a conductor. So it can be taken as inverse of resistance. So your G is equal to 1 by R, which is inverse of resistance. So we'll write the resistance formula and reverse it to get the final formula of conductance, that is Ka by L. So its SI unit is Siemens, which is ohm inverse. Now we study about conductivity. So the conductivity is the inverse of resistivity. So the conductance is inverse of resistance and the conductivity is inverse of resistivity. So conductivity is called specific conductance. It can be written as inverse of resistivity. So we'll get it to be like GL by A. So L by A is a cell constant. So we can define L by A as a cell constant. So we get the final value of conductivity to be G, that is conductance, into cell constant. So the unit will be 1 by ohm centimeter. And the factors which affect the conductivity are the temperature, nature of material, and the pressure. Now we'll be studying the different types of materials. So the first category of materials is the conductors. So these are the substances which have very large conductivity. For example, metals and their alloys, certain non-metals like carbon black, graphite, and some organic polymers are electronically conducting. Next, insulators. So these are the substances which have very low conductivity. Some of the examples are like glass, ceramics, etc. Next is the metallic conductors. So metallic conductors are those where the flow of electricity takes place due to the flow of electrons. That is, no flow of matter. So thus the matter will not decompose. Due to the vibration of the kernels, the electrical conduction decreases with decrease in the temperature. Next is the electrolytic conductors. So here the flow of electricity takes place due to the flow of charge. That is, the matter will decompose into ions. So the electrical conductivity will increase. That is, the electrolytic conductivity will increase with the increase of temperature due to increase in the decomposition of the metal. Next is the semiconductors. So semiconductors are those substances which have conductivity in between the conductors and insulators. So they have their conductivity in between conductors and insulators. Next is the superconductors. So these substances have zero resistivity or infinite conductivity. That is, metals in their alloys at a very low temperature. Nowadays, a number of ceramic materials are mixed with oxides and they show superconductivity at temperatures as high as 150 Kelvin. Now we'll be studying what is the electronic conductance. So, electronic conductance through a metal is due to the movement of electrons and is termed as electronic or metallic conductance. So it will depend upon the nature and structure of metal, the number of valence electrons per atom, and the temperature. So if the temperature will decrease, then the conductivity will increase. If the conductivity is reduced due to the increase in the temperature. Pure water have very low conductivity, but when it will be mixed up with the electrolytes, then they furnish their own ions and its conductivity will increase. So the conductance of electricity by ions is called electrolytic conductance. So there is a difference between electronic conductance and electrolytic conductance. Electronic is due to electrons, while electrolyte is due to the ions. So the factors affecting is the nature of electrolyte. So strong electrolytes have higher electrical conductivity because they have large ability to ionize. However, weak electrolytes will have low electrical conductivity. Next is the size of ions and their salvation. So, smaller the size of the ions of electrolyte, more will be their salvation, and hence large will be the electrical conductivity. Next is the nature of solvent and its viscosity. So in polar solvent, the electrolyte will ionize more as compared to non-polar solvent. However, lower the viscosity of the solvent, higher will be the ionic movement and hence larger will be the electrical conductivity. Next is the heat which is provided. So on increasing the temperature, there is an increase in ionization as the movement of ions will also increase. So consecutively, the electrical conductivity of the solution will increase. So it is directly proportional to the temperature. And the concentration of electrolytic solutions. So with the decrease in concentration of electrolytic solution, that is on dilution, the ionization of weak electrolyte will increase and thus the electrical conductivity will increase. Next, we will study about the measurement of the conductivity of ionic solutions. How do we actually measure the conductivity of ionic solutions? So the unknown resistance of a conductor can be measured easily using Wheatstone bridge. However, the resistance of an ionic solution from which we calculate its conductance will be difficult to measure. So in order to measure the resistance of an electrolytic solution, the Wheatstone bridge is used. So in this method, we generally encounter two problems. The first problem is the passing of the direct current changes the composition of the solution. The second problem is a solution connection, that is the solution cannot be connected directly to the bridge. So what is the solution for the two problems? For the first problem, we can substitute the direct current with alternating current. And the second problem can be solved by using a specially made vessel called the conductivity cell, which is made up of two platinum electrodes coated with the platinum black. So this can be the structure of the conductivity cell, and the area of cross section of the electrodes is A, and they are separated by a distance L. And then we'll be able to find the resistance, and we will also understand that L by A is a cell constant which is represented as follows, and the cell constant value is L by A, which can further be written as R into K. That is the conductivity. So we can measure the cell constant by a following way, that is the resistance of the cell is measured with KCl solutions whose conductivity at different temperatures and concentrations is already known. And then the resistance of an electrolyte can be measured by using a cell that is based on the Wheatstone bridge principle. Next, we'll study how we will actually measure the resistance of unknown resistance, how we'll actually measure the unknown resistance. For this, we'll take a Wheatstone bridge setup. So in this, R2 is the resistance of the electrolyte which is to be measured, and R3 and R4 are known resistances, and R1 is variable. So R1 can be adjusted until no current will pass through the circuit, and O is the source of the AC power called the oscillator, and under the no current condition, minimum or no sound can be heard from the earphone, which is P, the detector. So when no current will pass, R1 by R2 is equal to R3 by R4 according to the Wheatstone-Bridge principle. So from this we can find the R2 value to be R1 into R4 by R3. So once we will know the cell constant and the resistivity of the electrolyte in the cell, then the conductivity can be measured using the formula. And the conductivity of a solution will depend upon the charge of the ions and the size of the ions in which they will be present, and the concentration of ions and the ease with which the ions move in the solution under a potential gradient. In other words, the same electrolyte will show different conductivities at different temperatures and in different solvents. It is a very important point to note. So until now we have studied the basic terms related to the conductivity. In the next class we'll be studying about the molar conductivity and the strong and weak electrolytes, Kirchhoff's law, and now we'll give a quick NCERT reading. In the previous part we have studied the Nernst equation and we have completed the electrochemical series, and the first is the Fe and the least is the lithium plus, and these are the 2 points which are to be noted. The negative E0 means the redox couple is a strong reducing agent, while positive E0 means the redox couple is a weaker reducing agent. And we have completed the equations of Nernst with electrode potential and EMF of the cell, and these are all completed, and we have also discussed how to find the equilibrium constant Kc and the electrochemical cell and the Gibbs energy of the reaction and what is the reaction at the end, and chemical equilibrium is also studied. And today we have understood some basic terms regarding the conductivity, and we knew the formulas of conductivity and resistivity and their units, and we also studied about the electrical conductance and the factors which will affect and the electrolytic conductance. And this is done. This is the conductivity cell. This is another kind of conductivity cell, and we have studied how to find the unknown resistance with the help of Wheatstone-Bridge, and we know that this is represented as the cell constant. Some questions are provided for you, and the next part will be studying and starting from the molar conductivity. Thank you so much for watching. Stay tuned for more videos.